You know that feeling, right? That moment when something critical just breaks down unexpectedly. Maybe it's like a pipe bursting at home or some vital equipment failing at work. And suddenly you're not just fixing something, you're in full-on crisis mode, just reacting, scrambling because it already went wrong.
Yeah.
Well, today we're doing a deep dive into how artificial intelligence, AI, and these advanced digital tools are, well, fundamentally changing the game in operations and maintenance. We're looking particularly at critical infrastructure, think water and wastewater systems. Our whole mission here is exploring how these innovations are moving us away from that reactive fix-it-when-it-breaks mentality towards something much more proactive, preventing failures before they even get a chance to happen.
Yeah, exactly. And it's more than just, small adjustments. It's really a fundamental philosophical change we're talking about. The insights we're digging into today, they come from a really detailed set of notes, reflections on a presentation from WaterGem 2025, plus some extra research we pulled together. We're boiling down these powerful sort of general ideas about how AI is making a huge impact on O&M operations and maintenance.
Right, so this whole shift, moving from firefighting to actual foresight, it's not just for the big utility companies, is it?
Not at all.
It sounds like a blueprint almost for efficiency, for resilience, smart resource management, and that has implications way beyond utilities, maybe even in, our own lives. Okay, so let's unpack this properly. Before we get into the nitty-gritty of the tools themselves, maybe we should talk about the big players. Who's actually driving this change, especially in critical infrastructure, and what gives them the kind of leverage to speed up this transformation?
Well, a really good example that came up in our source material is Jacobs. They're a huge international firm. Engineering, consulting, O&M, facility management, they do it all. What makes them stand out, particularly for water and wastewater, is this full-service model they have. They handle contract operations, facility management for all sorts of clients, public agencies, private industry, you name it.
Ah, okay, so it's not just like one piece of the puzzle. They're looking at the whole thing.
Precisely. That's what's so compelling. They integrate the consulting, the engineering, construction, design, and operations all under one roof. And because they have this holistic view, they can actually influence the entire life cycle cost of an asset. They're not just jumping in to fix things short term. They're building in that foresight right from the design stage all the way through to how it's managed day to day.
And I'm guessing digital solutions are pretty central to making that work at scale, not just traditional methods.
Oh, absolutely central. They've developed their digital OneWater suite. It includes platforms like Intelligent O&M, AquaDNA, Dragonfly, tools like that. These are specifically designed to optimize operations, especially now with pressures like, climate change, tighter regulations, even workforce shortages. Their Intelligent O&M platform, for instance. It basically digs through tons of data from all sorts of signals. Think SCADA systems, that's the main control system, sensors, operator logs, everything. It takes all that raw input and distills it down into prioritized insights, actionable recommendations, stuff that drives efficiency and helps prevent problems.
Okay, so it's Jacobs' combination of their sheer size, their experience, and this integrated approach that really positions them to lead this shift, moving us away from just reacting when things break towards actually predicting and preventing. Optimized scheduling, better long-term planning.
That's exactly it. That's the power of their model. They can take this vision and actually make it happen scalably in the real world.
Okay, fascinating. Now let's pivot to the tools themselves. The AI, the digital solutions making this shift happen. What are some of the key capabilities here, and how do they really change the way, say, a water utility operates day to day?
Right, this is where it gets really interesting. This is the core of it. We can kind of group the AI toolkit into a few powerful categories. Each one tackles different problems. Probably one of the most impactful is predictive maintenance, PDM for short.
Okay, so that's about knowing when something's likely to fail, not just if it might fail someday.
Exactly. PDM uses sensors, historical data, real-time operational data. It monitors things like vibration, temperature, flow rates, pressure, and it uses all that to predict equipment failure before it occurs. So instead of waiting for a pump to just seize up, the system flags an anomaly, maybe weird vibrations. And then maintenance can be scheduled proactively, planned, not rushed. Oracle, for example, uses AI for this in industrial settings. And there was that project mentioned in Wrocław, Poland, using AI to predict leaks and pipe failures in their water and sewer networks. The really key idea here is moving from just scheduled maintenance, like change the oil every 5,000 miles, to condition-based maintenance, doing the work only when the actual condition warrants it.
Makes sense.
And building on that proactive idea, another really crucial capability is automated and optimized preventive maintenance scheduling. This uses AI heuristics. Those are like smart rules of thumb for problem solving and optimization algorithms to plan out maintenance tasks dynamically. It considers the equipment's condition, how critical it is, staff availability, and it often integrates with existing systems like CMMS or EAM platforms. There are tools like Timefold, for example, that specialize in optimizing schedules for technicians, minimizing travel, downtime,
Yeah.
that sort of thing.
Wow, okay. That sounds like a huge improvement over just static calendar dates. Much more responsive, much more efficient use of people's time.
Absolutely. The gains in efficiency, better resource use, cost savings. Which brings us nicely to another powerful tool, the digital twin, or system modeling. This is where you create a virtual replica, a dynamic model of a whole facility or network, like a water treatment plant and all its pipes out in the city. It lets operators simulate how things behave, do what-if planning, model potential failures, optimize flows, all in a safe virtual space.
So it's not just a static diagram. It's like a living, breathing digital copy that helps you make decisions. A partner almost.
Precisely. Digital twins are popping up in the water industry for all sorts of things. Optimizing water consumption, forecasting demand, planning maintenance schedules. The really profound implication is that you can test scenarios like what happens during a heat wave or a major storm. You can optimize your capital spending plans, get much better long-term risk assessments, all without touching the real system.
Sounds incredibly powerful.
It is. Though, admittedly, building and calibrating a really accurate twin takes significant effort and good data. Then, working alongside these, you have anomaly detection and condition monitoring. This is constantly scanning sensor data in real time, looking for anything unusual or any sign of degrading performance, maybe a sudden pressure drop that could mean a leak, or weird vibration patterns coming off a pump motor.
Catching those little warnings early, before they turn into big, expensive problems.
Yeah.
That must be incredibly valuable.
Huge. It allows for that early intervention. It significantly reduces the impact of problems, often means you can schedule a fix instead of dealing with an emergency, and it helps with regulatory compliance too. Next up, focusing on the people side, is resource and workforce scheduling optimization. This uses AI to figure out the best way to assign maintenance staff or even contractors, matching the right skills to the job, scheduling around operational needs, minimizing travel time, idle time. It's often called smart scheduling.
Yeah.
Basically, getting the right people to the right place at the right time, efficiently.
Right.
Then there's a newer category, but it's incredibly powerful already. Generative AI and assistance for planning, reporting, even decision support. Think about using AI to summarize really long, dense reports, or assisting engineers with complex decisions, suggesting schedule adjustments on the fly, even guiding operators through procedures. It's like an intelligent co-pilot for the O&M team.
That sounds like it could really unlock a lot of buried knowledge, make complex information easier for everyone to access and act on.
That's exactly the idea. It cuts down on manual work, speeds up decisions, improves how information flows, and it makes that tacit knowledge, the stuff experienced operators know but isn't written down, much more accessible. Of course, you have to be careful about accuracy, making sure the AI's output is auditable. That's still critical. And finally, there's prioritization and risk-based asset planning. This capability uses AI to rank assets, pipes, pumps, valves, whatever, for maintenance, repair, or replacement. And the ranking isn't just random, it's based on calculated risk. It combines the likelihood of something failing with the consequence if it does fail. Plus other factors like the asset's current condition, its age, environmental impact.
Okay, so that's a much smarter way to spend limited money, right? Making sure you fix or replace the things that pose the biggest actual risk, not just the oldest things.
Exactly. It helps make the best use of limited capital and O&M funds, reduces critical failures, and it makes decision-making much more defensible. That Root project used this for prioritizing their network rehab within their budget.
Right. So we've got this amazing toolkit laid out. But what does it all actually mean on the ground, day to day? How do these high-level concepts turn into real-world applications? And importantly, what are the big hurdles organizations run into when they actually try to implement this stuff?
Excellent questions. Because, implementation is where theory meets reality, and it's not always smooth sailing. Maybe before we jump into Jacob's specific examples, let's quickly touch on those common challenges, because they tend to apply across the board with these AI tools. First big one is usually data infrastructure and quality. AI needs good data, simple as that. So do you have enough reliable sensors? Good SCADA coverage? Is your historical maintenance data clean, well-structured? Got good metadata, details about the asset, when it failed before, its condition. Without that foundation, the AI is flying blind. This ties into integration challenges too. These new AI tools have to talk to the existing systems, CMMS, maybe the URP system, the control systems. The recommendations from the AI need to actually trigger work orders, manage parts, make things happen.
Right, it can't just be a separate system spitting out reports nobody uses. And then there's the people side, I imagine. Always the trickiest bit with new tech. Always.
Which brings us to change management and trust. Operators, technicians. They might be skeptical of AI suggestions. Why trust a black box? So, transparency is key. Explaining how the AI reached a conclusion. Often you still need human oversight, especially with safety and regulations involved. Conservative strategies are usually necessary at first. Then there's the scalability and maintenance of the AI models themselves. They aren't set it and forget it. Models drift, they need retraining as conditions change, and the sensors feeding them data. They need maintenance, calibration, plus more digital data, more connections. That means more potential doors for cybersecurity threats. The whole system has to be built securely, resiliently.
And justifying the cost up front must be tough, too.
Definitely. You need clear cost-benefit analysis, ROI clarity. What are the actual metrics you're trying to improve? Often, starting with smaller pilot projects on high-value problems is the best way to demonstrate the value and get buy-in.
Okay, that makes sense. So, bearing those challenges in mind, how does a company like Jacobs actually put these tools into practice? Let's get into those specific examples.
Right. Let's look at how Jacobs translates these concepts, really focusing on that human element and the cultural shift involved. One brilliant, almost deceptively simple example is the digitization of vendor manuals.
You mean those incredibly thick technical binders you get with every pump or valve? The ones nobody can ever find when they need them.
Exactly those. Instead of letting those PDFs just sit on a server somewhere, or worse, stay in paper binders, Jacobs scans and uploads them all the maintenance tasks, the parts lists, the recommended intervals, right into their CMMS system. But here's the magic part. AI then ingests all that unstructured data. It reads those thousands of pages and pulls out the actually useful information, specific things like lubrication intervals, torque settings for bolts, wiring diagrams, and crucially, it does asset recognition and location mapping. It connects the equipment IDs in the manual to the actual physical assets out in the plant or field, so a mechanic working on pump A gets the exact info for that specific pump instantly.
Wow, that alone sounds like it would save an incredible amount of time and frustration, turning dead documents into a live, searchable knowledge base.
It's huge. And a really key detail here is the AI's logic, transparency, and accuracy. Our sources mentioned it's around 85% accurate, which is good, but humans still verify. But the AI shows its work. It links directly back to the source page in the manual where it found the information. That builds tremendous trust with the operators. It's a co-pilot, not replacing them. And, this is critical, it's a closed system AI. It's not like using ChatGPT on the public internet. Jacobs's AI is trained only on the utility's own documents, their own data. That means no weird hallucinations or making things up. It keeps sensitive operational data secure. The utility owns the data, owns the insights, it saves time, builds that institutional memory, and really helps shift the culture towards being proactive.
That closed system point is really important. Okay, what else?
Building right on top of that digitized knowledge base, they integrate AI chat functionality. Think of it like a specialized internal search engine, but you talk to it. Users can ask questions in plain English, like, when was pump 3 last serviced? Or what's the vibration limit for this specific motor?
So staff can literally just ask questions and get answers drawn from all that internal data manuals, work orders, procedures, makes knowledge instant.
Exactly. The AI searches across the CMS data, the digitized manuals, standard operating procedures, SOPs, even past work order notes. It just democratizes knowledge, makes problem solving faster, helps new employees get up to speed way quicker, and it turns all that historical data, which used to be locked away, into a living, usable resource, institutional memory you can actually talk to.
That's powerful. What about scheduling? You mentioned optimization earlier.
Right. Another key application is the scheduling overlay. The AI acts as a co-pilot for the planners and schedulers. See, traditional CMS systems can be pretty rigid. They assign preventive maintenance based on fixed schedules, maybe run hours. They often struggle to adapt dynamically to emergencies or, importantly, those early warning signs from condition monitoring. So Jacobs uses an AI layer that sits on top of the existing CMMS. This layer runs much more advanced optimization algorithms. It prioritizes tasks based on risk, cost, criticality. It can dynamically juggle the schedule when something urgent comes up, rerunning the whole optimized plan in minutes, not hours or days. And it presents it all on visual dashboards.
Okay, so the AI does the incredibly complex number crunching, figures out the optimal sequence and timing, but the human planner still has the final say.
That's it, precisely. The planners get this incredibly powerful co-pilot handling the heavy math, leaving them to apply their judgment, deal with exceptions, manage the people. It really helps shift that workload balance, less time juggling, more time preventing.
Makes sense.
Yeah.
And how do the people in the field interact with all this? The mechanics, the operators?
Crucial question, because user adoption is everything. If it's clunky, nobody will use it. So Jacobs developed a field portal for operators and mechanics. Its design, mobile first, works easily on tablets, smartphones, very intuitive interface, gives them quick access to their work orders, step-by-step instructions, those digitized manuals we talked about, safety procedures, everything they need right there. And importantly, it makes input easy too. Tapping checkboxes, taking photos, even adding quick voice notes. It just reduces the friction of capturing information from the field.
So it closes that loop between the office planning and the actual work getting done, and build up that history for each piece of equipment.
Exactly. It creates that living, dynamic history, which then feeds back into the predictive models in planning. And finally, tying many of these threads together is how they implement condition-based maintenance, CBM. We touched on this, but it's worth emphasizing the difference. Traditional PM is fixed schedule, change the oil every 3 months, regardless of how much the machine actually ran or how hard. That can lead to doing maintenance too often or worse, not often enough. AI-driven CBM, though, uses that continuous stream of real-time data runtime, vibration, flow rates, energy consumption. If a pump starts working harder than usual, maybe drawing more power, the AI flags it and increases its inspection priority. Conversely, if another identical pump is barely used, maybe it extends the maintenance interval for that specific unit.
So it's like your car knowing how you actually drive lots of short city trips versus smooth highway miles, and adjusting the oil change reminder based on that, not just the odometer reading.
That's a perfect analogy. It's way smarter than a one-size-fits-all schedule. For the utility, this translates into huge efficiency gains. Labor, parts. They get used where they're genuinely needed most. It boosts reliability because the assets showing signs of stress get attention sooner, and it helps with that cultural shift because maintenance adjustments are based on actual evidence, not just the calendar. And crucially, it helps get buy-in from the field techs. They see it reducing the amount of, frankly, unnecessary busy work PMs, letting them focus their skills on the tasks that really matter.
Wow. Okay, this deep dive really paints a picture. It shows how data, when you combine it with these intelligent systems, it's not just about making small improvements here and there. It really is about fundamentally rethinking how we manage these complex, critical systems, making them more resilient, way more efficient, and ultimately more sustainable. This whole transformation, moving from just fixing what's broken to actually preventing the break, it really feels like a genuine game changer.
It absolutely is. When you see how AI can be integrated across all these different facets of O&M, from digitizing those manuals to create a knowledge foundation, to using AI chat to make that knowledge instantly accessible, then adding dynamic scheduling and condition-based maintenance to enable proactive intervention. It creates this powerful operational synergy. It's really redefining what's possible.
So thinking about how powerful this closed system AI is just for unlocking all that trapped institutional knowledge within a utility, it makes you wonder, doesn't it? What unstructured data might you have in your own professional life or even your personal life? Those old binders, maybe decades of notes, those digital files buried somewhere. Could similar AI principles unlock that knowledge and fundamentally change how you plan or manage things or even how you learn? Something to think about.